Hi, Bruce Wood from Tinius Olson again, discussing the accessories and fixtures required to fit on the metal impact machine that we looked at in the previous video. Before we go any further, there are two basic test methods for impact. One is IZOD, where a sample is mounted vertically, like the letter I, with the notch on the side that is struck. The sample is hit and it breaks at the notch and folds over, just like a stick. For an IZOD test, you would need a clamp, and you also need some accessories to allow the notch to be located correctly in the machine, and then it can be tested. The striker for an IZOD is this style of striker with the bull nose on it here. It has 4 mounting locations with the recessed bolt pattern here and 2 jacking points to allow it to be extracted from the hammer. The final location up here, this pin, allows orientation of the striker to be tightly controlled so that you have the striker correctly aligned with the sample. This will fit in a standard metal impact hammer and therefore can be switched out if needed. The other form of impact test is a Sharpie impact, where the sample is laid horizontally and is hit on the opposite side from the notch. When the sample is hit, it then breaks like a carrot in the center. There are 2 different strikers for this. Normally, there is what is considered to be the ASTM striker, which is the 8mm striker with a bull nose here, which has an 8mm radius on it. And then these 2 radii on the sides are very tightly controlled and obviously are monitored to maintain the shoulders. Again, the 4 mounting locations that you have and the 2 jacking locations to allow it to be extracted, along with the location pin for orientation. The ISO striker is the 2mm radius, and the difference is apparent in the fact that there's a simple 2mm radius on here. It is not a shoulder, it is a 2mm radius directly to the striker itself. Again, same mounting locations because it bolts into the same hammer. Now, we call this the ISO striker, but that is actually a misnomer, as both ASTM and ISO allow the use of the 2 and 8mm strikers. So realistically, normal testing would depend upon exactly what you need to test. The samples themselves get loaded into a machine for Sharpie testing using the set of tongs that you saw being used when we were demonstrating yesterday. Those samples get picked up and held in the tongs, and then this spacing here is just the same spacing as the gap between the anvils, allowing the sample to be located perfectly within the center of the anvils. You'll notice that this backside here is where the striker will hit, and that's the opposite side to the notch. The anvils themselves, these are common for both ASTM and ISO, and these are new anvils. You can see there's quite a nice radius on here that covers the entire distance, and they are recessed across the back so that the sample does not get wedged between the anvils during a test. There are 3 mounting bolts per anvil. There are 2 which locate it back against the machine, and 1 which actually holds it to actually set the spacing on the anvils. This spacing is tightly controlled by the body of the machine itself, therefore ensuring that these are torqued to the correct spec in the correct order is very important. So those are the basic components of the metal impact machine. One of the things that is required is an annual direct calibration of the machine. The ASTM E23 requires both direct and indirect. Direct verification monitors the spacing between the anvils, the radii of the various components, and the torque and level of the machine. Obviously, it is not possible for a technician to read the radius of this profile here with his naked eye, so what he actually will be doing is he will be taking a aluminium or aluminum replicant like this and placing it between the anvils and striking it with the hammer. When it is struck, this will then leave an impression of both the striker and the anvils, allowing us to monitor those devices. Here is a SLAMI that has been struck, and you can see the impression of the striker at the top and the two anvil impressions on the side. This is then measured on our comparator here in the office, and we compare the radii that we see from this impression against what the radii are required to be according to the ASTM or ISO specification, and we can monitor the radii of the anvils at the same time, along with spacing and centering. This is direct calibration. The indirect calibration is where NIST specimens are tested. These are typically a standard reference material that's very tightly controlled and manufactured to the highest specifications. A NIST specimen looks like this, and it comes with 3 batches of 5 samples. There's a low energy, a high energy, and a super high energy sample that allows you to test the actual energy outputs from the machine. These samples may need to be chilled to a specific temperature, checking the temperature of the bath, the operator use of the machine, and the machine itself. Those values are then sent to NIST, who then give you a thumbs up or a thumbs down on each range to say that it passes or fails. NIST also examine the samples to see if there is signs of wear or damage on either the anvils or the striker. This is a sample I have previously broken, and there are witness marks to show where it actually struck the anvil and where the striker was. Now, it is not easy to see on this sample where the anvils were, but if those anvils were in poor condition, they would smear and they would leave marks on the sample indicating wear. Although NIST cannot actually measure the samples because the survey they send out with the material is, does the machine meet the requirements, they will actually recommend that anvils be addressed or the striker may need to be recentered. Obviously, anvils that have worn, like these items here, you can visually see there's a wear pattern where the samples were sitting and have basically worn out that particular sample. This would be visible to the naked eye, and this one failed very badly. However, when you get to that borderline, does it pass, does it fail, we rely very heavily on our SLAMI, as we call it, to verify that profile is actually within the tolerance of the machine. That is one of the benefits of a direct calibration. The strikers also leave an impression, and this striker here has a failed striker corner, and it is possible to see with the naked eye a witness mark on the side of here showing that it has worn. There is some hourglassing on the front, which skilled technicians will see and identify as potential wear, requiring that the anvil be replaced. All these items can be ordered and then replaced. Technicians typically would do this work. However, anybody who has the calibration experience can do it, and then the standard reference materials were required to break to complete the calibration of a machine. There are many other options available with the Metal Impact, caged or uncaged. The capacity of the machine can be varied, along with other options and so on and so forth. Check all the brochures and information that we have for the machine to see what other options are available, and obviously call Tinius Olsen or your local representative if you require further information.